Hello everyone, it's Benny, and in this video, we're actually going to start adding some logic to our monster, making the monster chase us, and if we have time, maybe we'll start trying to get the monster to attack us. But, first, I just want one slight reminder from last time. I am changing the method back to my method. Again, I'll go over that in video 32. It doesn't affect you. However, I did change a parameter, and that is I've changed the GL linear to GL nearest. If you're using slick util, then there should be something in this method where I'm passing GL linear. Just change that to GL nearest, and it'll look exactly like me, or exactly like what I have. So, with that, let's go ahead and start adding some logic to our monster. Now, the way I'm going to do this is I'm going to have a bit of a state machine going on. The monster's going to be in one of 5 states, and depending on what state it's in, it's going to do something. So, public static final int state idle. That's going to be our first state. We can have 5 of them, so 1, 2, 3, 4. And let's see, after an idle, it can be chasing us, it can be attacking us, it can be dying, or it can be dead. And it's going to have some private int just to keep track of which one of these states it's in. And of course, it's going to start off idle. Wait. So, state idle. And just to go over what exactly it's supposed to do in each of these, when it's idle, it's not going to do anything. It's just going to do sort of like a 1-2 animation, just sit there until it sees the player. When it sees the player, it'll enter the chase state. And in the chase state, it'll start chasing around the player, and at a random chance, it might move into the attack state. And if it's in the attack state, then it's going to shoot something at the player, or try to anyways, and then go back to chasing it. And it's going to keep doing that cycle, chasing till random chance, then attacking, then going back to keep chasing it, until eventually the player kills it, in which case it'll enter the dying state, and play its little death animation, and then it'll be the dead state, where it's just stationary, and showing, well, the dead sprite. And that's how the state machine is going to work. And the way I'm going to do this is with a switch statement. Switch based on state. Case state idle. And I'm just going to break, and I'm going to have one case for every single state. So, yeah. And dying. Whoops. And dead. So there. And I'm going to have an error because duplicate... Oh, right, I didn't set these, excuse me. Chase is going to be state 1, they're just increasing order. So yeah, that's how I'm going to... And the exact number of the state really doesn't matter. You can make these any numbers you want. I'm just going in order because, well, it's easy. The only important thing is that states are distinguished. And here's how I'm going to handle this. I'm going to have some different methods for every state. So, idle update, public void, chase update. Wait, it shouldn't be public. These should be private, excuse me. So, private void, attack update, private void, dying update, and private void, dead update. That's exactly how my state machine is going to work here. It's just going to call whatever method depending on what state it's in. And, yeah, nothing too fancy here. This is just really the logic framework. But don't worry, well, after this, in fact, we'll have all of the framework set up, so we should be able to actually start implementing some logic. And this is where things will get a little bit interesting. But actually first, let's just run it and make sure I didn't destroy anything with the state machine. So if I run... Oh, that's GitHub, don't need to worry about that. And, okay, cool. Actually, just to make sure it's actually updating, because I'm not sure I'm updating. Wait, system dot. And again, this is just setting up stuff. It's not really something fancy. So in fact, let's just print that out, something fancy. That's what we'll see if indeed we're updating the monster. Are we? Yes, okay, cool. So the state machine is theoretically working, and we're not getting any errors. So, excellent. Now we can go ahead and start implementing these states. Now before I go off and just start implementing a whole bunch of logic all over the place for this state and that state and whatnot, there are a few things that we're going to want to update regardless of state. For instance, if I run, you notice, well, we have our monster. But, well, for one, he doesn't really face us, and that's a bit of an issue. We want the monster to, always stay facing the camera. So, that's one thing. Another thing, although with my texture loader it doesn't appear to be an issue, if you're using Slick Util, you are going to have, well, if you're using Slick Util on the offset system that I had, you're going to have issues where the monster is slightly above the ground. And that's not really what we're going for. So, let's go ahead and do that. I'm going to have in my update method, first off, the easy one. We're going to make the monster stay aligned with the ground. And that's going to be easy enough. I'm going to transform.getTranslation.setY. And it's going to, I'm going to have this as offset from ground. And it's going to be public static final float called offset from ground. And in my case, it's going to be equal to 0, 0. In fact, I should do this. I'm going to put the Slick Util values in comments. So let's see, I believe that was 0.01 and this is 0.05. Or maybe I have that backwards. I'll check at the end of the video and correct it there. But if you're using Slick Util, you should have those in place. And this one, the value I have noted down is negative 0.075f. That was the offset I got from Slick Util. And that should align with the ground properly. Or if not, at least get very close. So cool, we got, well, right now if I run it's not going to do very much. But now it is staying in line with the ground properly, even if you are using Slick Util. So yeah. But, of course, we still have the issue of we need the monster to face a player. And the way we're ultimately going to do this is we're going to take the transform and set the Y value of rotation to some angle to face the camera. But, well, that can be a little bit tricky. So, let's figure out how to do that. Or, actually, you know what? Let's add some methods here. Let's put these in methods just to make it a little bit clearer what exactly we're doing. So to start off with, I'm going to start off with that, so align with ground. That's going to, just to make it a little bit more obvious what I'm doing here. So we're going to align with the ground. And I'm also going to have one more private method, which is going to be face the camera. And there. Just to make it a little bit more apparent what exactly this code is supposed to be doing. It's not just a bunch of code thrown all over the place. It is a little too late to redeem this and make it, decent coding practices, but I may as well do what I can. So yeah, that's what we're going to do in the update. Line with ground, face the camera, and then act based on... What? Okay, I don't know what I did there, but we'll act based on states. Anyways, what we're going to do now is we're going to calculate the angle from the camera. And here's sort of how I'm planning on doing that. First off, we're going to figure out the direction to the camera, and then we're going to do some trigonometry to figure out what angle we're going to have to, use to make it face the camera. So, I'm going to say transform.getTranslation, and I'm going to subtract the transform.getCamera.getPosition. And there, now that we have that, we now know the direction. If I assign it to something, that is, so vector 3f, direction to camera. Whoops, no. So there, now we know the direction to camera, but how are we going to actually calculate something meaningful out of this? And this is where Paint.net comes in. So I'm going to draw a basic axis. This is the, okay, maybe I don't want it that extreme, but this will be the x-axis, and this will be the z-axis. And what this vector is going to do, I'm not going to care about the y value. I don't care what the y offset is. I only care about the XZ offset. So let's say the Z offset's right here, X offset's right here. That means the direction will, if I line it right, yeah, it's not aligned right, but okay. There. It'll be something like that. And what we're going to want to do is we're going to use some trigonometry to calculate this. We know the adjacent, and we know the opposite. So, if you know that, I believe the saying is like SOHCAHTOA or something, then you should know that the appropriate tool for this is tangent. Tangent is opposite over adjacent. So that's exactly what we're going to do. We're going to take the opposite, which is the z component, divided by the adjacent, which is the x component. So z over x. Then we're going to take the arc. That will give us the tangent of the angle. We'll use the arctangent operation to get us the actual angle. So that's what we're going to do. So direction to camera dot get z divided by direction to camera dot get x. And we're going to say math dot arctan of this to get us the angle. But this will give us the angle in radians, so I want to do 2 degrees to calculate this. And that will get me the angle to face the camera, which will be a float, after I cast this to a float. And with that, we should be able to have this thing mostly facing the camera. You'll see what I mean. It's... oh, I think it's facing directly away from the camera at the moment. Maybe I have it backwards. Let's try that again. So, negative that. I think I might have... okay. Yeah. It's sort of working. Just something's going a little bit weird. And what gives? Well, I found that when you do this, you actually want to reverse it. You want to reverse the angle based on whether it's based on the x value. And I actually don't remember the exact thing I did to correct that, so one moment. Okay, let's take a step back here. Let's not make this negative. Let's run with the invisible sprite, quote-unquote, for a moment. You see, it's invisible. And what gives? Our calculation should be correct. And it is. Here's the first issue with this. The first issue is just the orientation we created the plane in. Because of the orientation we've created the plane in, then this angle, although correct, will make it face the camera edge on. Which, I mean, it's technically correct, it's just we don't want to see the plane edge on, we want to see it face on. So, I actually want to add 90 to it, just so our plane shows up in the proper orientation. Again, this value is correct, it's just I'm rotating it by 90 degrees in order to make the plane face the player. And now if I run, you see, it's working. Except when it isn't. What gives? Why does it only sometimes working? Why other times does it just strangely reverse? And this is best demonstrated with the power of a print statement. So system.out.println. Yeah, I want to just print out the angle to camera. And if I run, you'll see it's working. And when I do this, all of a sudden, it's reversing. It's going from like negative to positive. You might be wondering, well, why is that? And well, the thing is, the tangent function, or arctangent function, when converted to degrees, will give you an angle between negative 90 and positive 90. And that's great, except our rotation needs angles between 0 and 360. Well, it does work with negatives. It could go from negative 180 to positive 180. But still, it's not giving it into the appropriate range, because it doesn't have enough information just based on the angle. There's multiple solutions to it. So, if it gives us the wrong solution, we need to correct that. And here's how we do that. if direction to camera.getX is positive, because this is when it should be wrong. And just to prove that to you, I'm going to print it out only here. You can kind of tell by looking, but just to prove it to you, yeah, see? It's only printing out the angle when he's invisible to us. And you can kind of see that. It's when we cross into the positive x-axis that the thing goes invisible. So, what I want to do, or well, not when we cross into it, when we cross into positive relative to the enemy, not absolute. But anyways, you get the idea. It's when we cross it's all based on the x-axis, whether it's positive or negative. So what we want to do is, in this case, just take the angle to camera, add 180, or well, plus equals 180. And that way, it will give it the proper space, exactly the sort of orientation we're looking for. It will adjust it so it's in the proper space. And now, if we circle around the enemy, look, he's always facing us, just like we want. Now this isn't perfect. It doesn't take into account the camera's orientation. If you want to take that into account, to make it face it correctly even then, it can be really tricky to do. But for the most part, the enemy's working just fine. We have hacked sprite support. Congratulations! Actually, I've decided that this is probably a good time to go ahead and stop. We just covered sprites, so in the next video, we're going to go ahead and start making our monster chase us around. And probably collide with things and open doors and do other smart chasing behaviors. It's got to hunt us down, you know? So yeah, that's what we're going to work on next. Thank you. Hope you enjoyed. Hope you learned. See you next time.